Hello everyone, welcome to another exciting video, and in this video we are continuing the next part of HPA and a VPA. As in a previous video, we have covered the concept of HPA and a VPA in a Kubernetes, how HPA and a VPA works in a Kubernetes. So in this video, we are going to hands-on with HPA and a VPA in a Kubernetes environment. We are going to use the kind cluster. So without any delay, let's get started. So as a prerequisite, launch the EC2 instance of T3 medium or higher, whatever you want, of a Ubuntu's image. And after that, connect to that instance. So in my case, I have already launched and connected to that instance. Okay, so you can see. And after that, update the system. And next, install the Docker and enable it. So in my case, I have previously installed and add the Ubuntu user in a Docker group and refresh the Docker group. You can check the Docker version after installation and also check whether the Docker PS is working. So you have permission to visit Docker. And next, you need to install the kubectl. Kubectl helps to communicate with the kind cluster. Okay. After that, move the kubectl into binary so that it can work as a command. And you can check the version using this command. So everything mentioned in this readme.md, okay? And after that, you need to install the kind as we are going to run our workload on a kind cluster. So kind is a type of a cluster we are running inside a Docker. So this is the thing why we need to install the Docker also. You can use Minikube or EKS, whatever you want. So for this demo, we are using the kind. So you can also check the kind version. So our kind installation is also done. So let me explain the project directory. So this is the HPA folder which contains the HPA manifest, and VPA is a VPA manifest, and this is the cluster config which we are going to use to create the cluster. So in Kubernetes, everything is a manifest. Whatever you write in a manifest file, it create for you. So this is the README that you can follow to apply this hands-on. I will share this repository into a comment section or a description. And after that, we need to create the kind cluster. So let me explain the kind cluster. So this is the kind as a cluster, and we API version as this, and we are creating two nodes. So one is a control plane and second is a worker. So to try this project, we need to clone this repository first. So I'm going to clone this repository. So you can see everything inside this repository has been cloned into EC2 instance. And after that, we need to create the kind cluster. So simply you can run this command where we are creating the cluster as a name of HPA VPA demo, and the config file path is kind config YAML, which is in a root directory of the repository. So this is going to create the two nodes, whatever we are mentioned as a one is a control plane and second is a worker, and is starting the control plane. So our kind cluster is ready. You can check kind get clusters, and to check the nodes we are using kubectl command, kubectl get nodes. So you can see both the nodes are ready. After that, we need to install the metric server. So metric server is basically needed for the HPA because metric server exposes the uses of a CPU, memory, and etc. whatever needed in HPA, so that we can scale our infrastructure based on the utilization of a CPU and a memory, whatever resources we are needed to. So install that using this command. After that, we need to configure the metric server for a kind cluster. In EKS or a cloud managed cluster, we don't need to do this step, as this is managed by them. For a kind cluster specifically, we need to add the deployment of metric server to add this line in. So this is the spec and containers, and in containers we need to add in arguments. So let's add here. So we just need to add this. So let's copy one by one and paste it here. By editing this, our metric server can expose the CPU utilization and memory uses. So we just need to save it. After that, we need to restart the deployment of metric server so that it can update it. So our metric server has been updated. You can check whether the all pods are running or not in a kube system, and you can check whether the metric server is exposing the CPU uses or not. So it will take around 2-3 minutes to get updated. So you can see the metric server are now ready to expose the CPU and memory uses of the pod. So now let's start with the HPA hands-on. So we need to apply this HPA and a VPA deployment and service. So let me explain this deployment. So deployment is or API object in a Kubernetes that manages the set of pods and replicas in a Kubernetes, which is a stateless. If the deployment has been deleted, your data has been deleted. And the service is used to expose our application deployment to the external world. And this is the HPA manifest, which is API version of auto scaling, which is as HPA comes in an auto scaling part, and API version is this kind is horizontal pod autoscaler, and this is the name of HPA. We are specifically targeting the deployment we have created, which is HPA Nginx, and we are setting the min replica as 1 and a max replica 5 based on the CPU utilization of 20%. So initially we are going to see one pod of the HPA Nginx deployment, and after based on CPU utilization our replica going to be increased and max is going to reach the 5 pods. After that it not going to be create any pods, so 5 is a max limit of the HPA we are setting, and this is the average utilization we are setting, so that if 20% going to cross the HPA, then we it started the creating another pods. So let's start with the hands-on of HPA. So we are going to apply the manifest created, and now we are applying the service. So our service and deployment has been applied. Now going to create the HPA. So our HPA has been created. So you can check by kubectl get HPA. So you can see initially it is showing unknown as a CPU uses. So you can see now it's showing the 0% usage. Let's generate the load on our application as targeting the service of our deployment as we have written. This is the service name. We are targeting to generate load on it. So I have created the load generator pod so that we can get at least CPU utilization. So initially you can see minimum pods is set to 1 and max is a 5, and currently we have only one replica of our application. So you can see the CPU utilization is increased to 9%. So I will launch the new terminal and connect to that instance in new terminal also and see the pod creation based on the CPU utilization increases. So let me connect to that instance. So I have connected that instance. Okay, so We are in a default namespace. We are everything created in a default namespace. So we can simply say -w. So -w is basically watching the command live time. And this is the our, so you can see the CPI utilization has reached the 18%. So it is going to be taking much time. So I'm going to create one more load generator pod. Basically, we are using the busybox image and creating the while loop in so that it cannot sleep and create a load as much we are looking for. So to creating, we are just changing the name of the pod and creating more and more generators so that it can reach the CPU utilization and create max pod. So we are going to create a more load generator. After that we are going to see how many pod it creates. So let's see. So you can see, yeah, it started creating the new pods for our deployment. And if we see the HPA kubectl get HPA, so you can see the average CPU utilization has been increased to 45%, but we have set it to 20%. So HPA is going to increase the number of pods. So initially we have one replica, now we have three replicas. So let's see how many it creates. So it creating, yes. So this is how HPA works generally based on the CPU utilization or the resources you said to increase the number of pods for your application. And if we generate more load generator, then you can see it going to reach the max 5. So let's do it. Okay. So so now we're gonna check the HPA is, so you can see our application has reached the max number of pods what we have set in a HPA. So now if you see kubectl get sorry kubectl get pods, you can see we have ready our 5 pods for application using the HPA. And if we delete all the load generator, you will gonna see how it decrease the number of pod also. So for that we can delete the kubectl delete pod. Okay, so we're gonna copy one. So we're gonna copy it and just paste it with the numbers how much we have created. We have created till 7. So we're gonna delete it and see how it decreased the number of pods for our HPA Nginx application. So we have deleted the load generator pod, and you can see in watch time, these are pods are going to be destroyed, terminated. Let's wait for a couple of a time. So now our load generator pod has been successfully destroyed. If we check the kubectl get pods, so still we have number of pods running. And if we check kubectl get HPA, so we have CPU utilization decreased to 2%. So horizontal pod autoscaler going to decrease the number of replicas also. So let's wait here how it decrease the number of pods. So it will decrease the number of pods gradually, not immediately after the CPU utilization goes in decreased. So it will take a couple of minutes to delete. So you can see all the number of pods has been destroyed. So if you check kubectl get pods, so you can see now we have only one pod running. You can check the kubectl get HPA. So you can see we have only one replica running for our deployment. So this is how HPA works. So it will take a couple of minutes to increase the number of pods. Also, at the time of low CPU uses, it will take couple of minutes to decrease the number of pods. So it will gradually decrease and increase the number of pods, whether checking the actual uses of CPU based on the load on our application. So let's move on to the VPA part. So this is the deployment of a VPA we are creating, as we have created for the HPA, same using as the nginx image, and this is the resource request and the limits for our pods, and this is the VPA we have created for our VPA deployment. You can see. So the API version for the vertical pod autoscaling is this, and kind is vertical pod autoscaler, as we are mentioning the target reference to our VPA deployment, and update policy is recreate. Basically, whenever the request has been provided by the VPA to increase the size of the pod, as we have previously learned, the VPA increase the size of pod. So it will create the pod again. So it will going to create the restart in your pods. So let's start the VPA part. So before that, we need to clear the HPA. So we have deleted everything created in HPA. If you can see kubectl, get pods. So everything is clean. So let's start with a VPA. So for that, we need to clone this repository. So you can clone like this, and we have to go inside this repository. Let's wait for to be get cloned. This is the large repository for autoscaler. It included the vertical pod autoscaler. In that, we need to run this script that going to install the VPA. I will show you the script also. So let's clone this repository. So this repository has been cloned. We're gonna inside that repos directory, and let's first cat the shell script for you. So this is the path. So so this is the script that has a copyright for the Kubernetes authors, and it install the vertical pod autoscaler of the default tag, which is has been set by them also. So this is the script we need to run. So we can run this using this line, and we after that we need to go back to our initial repo. Okay, then you can grab the VPA has been created or not. So you can see all the pods related to VPA has been running. So as I have explained in the deployment of a VPA, we are going to apply the manifest of VPA and going to apply the VPA also. We have the update mode as a recreate. So it's going to recreate as whatever the VPA suggests. So you can check the VPA recommendation using this. So it will take 2-3 minutes. So you can see VPA has mode as a recreate, and the next CPU of our pod going to be 25 M, and the memory should be 250 MI. And we have provided data to the VPA, and age is you can see. So in deployment, we have set the request as a 50 M and the memory as a 64 MI. If we can check kubectl get pods. So you can see this is the pod is running. So if we describe this pod, kubectl describe pod. So here we can see the limit has been set to the 500 M and the 512 MI. And this is the request we are making for this pod. So if we delete this pod and so as a auto scaling, it will going to create this automatically, and the VPA suggests that the next pod should be of a 25 M and 250 MI. So let's delete that pod and see whether it applies or not. kubectl get pods, kubectl delete. So it's going to automatically create this pod of this size. Okay, so it can handle this much of capacity. So the pod has been deleted. Now the new pod is going to created kubectl get pod. So you can see the age, it is running. If we describe this created pod, then if you see kubectl, sorry, describe pod. Now, if we see, the request has been set to the 25M and 250 MI using the VPA, and the limit has been reset to 250M and the 2000 MI. So this is how VPA work. So the VPA recommends you can see the recommendation of a VPA using this command. So this is the recommendation for our VPA Nginx deployment. So lower bound we have already set. So VPA has set to this CPU and a memory. The target is now this, and uncapped target is this, and upper bound when like millions of user going to hit your application, then your pod size going to be increased to this. So this is how VPA and HPA work. You can delete the all resources created inside it using this. So this is how VPA and HPA work in Kubernetes environment. You can try it by own also. I will share this repository link into description and comment section. And that's all for this video. I hope you learned something new. मिलते हैं next video में, तब तक के लिए जय हिंद, bye.